So since this is the first information presentation for the class that's associated with the notes that you're expected to study, I thought that I would begin by sort of explaining a little bit about how I would go through this course, how I would go through structuring, what I would do as I processed the important information and examples in the class, and then applied that to the various activities of the class. So again, if it were me, the first thing that I would do after orienting myself to the course website is I would download the course notes file. That's probably number one. So I would do that, and I would probably print out the notes, even though it's a lot of pages. I'd probably print them out, 3-hole punch them, put them in a binder, and then I would take a pen and I would augment the notes during these kinds of presentations. If I say anything as the teacher that helps to clarify the information or the examples presented, or if I need further clarity and you might go out and email me, or you might Google things, and then check with me to ensure that you really truly understand the information. But I would jot that information down in the notes. Now, you might be a different kind of person that way, and you might take the digital file and the Word version of it, and then if you needed to add anything to it, you might just keep it digital, and you might just jot down or type in anything that would help you better understand the information associated with each of the learning outcomes. So it's up to you, but the one thing I would say is that here you are in this first formal information presentation session, and it would be a really good idea to have those notes in front of you. And then the next thing I would do is I would take a look at the calendar of events, and I would go to my calendar, which I use an online calendar, Google, and I would go ahead and include all of those in the calendar so that you're super clear about when things are due. I suppose the last thing I would do would be in my browser. I would bookmark the course website, and then make sure, for me, I bookmark the D2L site, although I do have a link to that on the top of the menu up there. But you're going to need to go to that regularly as well. So that's what I would do to get started. And so now I'd like to present just briefly a little bit of summary or clarity information, and perhaps some further examples for the information for each of the objectives in part 1 of the class. And again, as I go through this, I can be a rather verbose person at times, and so I am going to actually time myself right here. I'm going to set my timer for 1 minute for each objective, and I'm going to summarize some important information about the objective to you, perhaps provide a story, keeping it short, and then and if my timer goes off, I am going to wrap it up and move on to the next, to information about the next objective. So all told, that should take approximately 15 minutes, since there are approximately 15 objectives for part 1. So I am going to pause briefly, and this is a good place to press pause on the video if you need to go and print off or download the course notes packet. So just wait a moment. So the first objective for the course involves you explaining what is meant by a Master of Science degree, and that's the degree type that you are currently earning. Now, first of all, I want to say this about that course objective 1.1, and that is that it's in italicized font, which means that I'm not going to be asking you to actually explain what it means to get a Master of Science to me. So that's something that I just want you to know, because this course uses the term science a lot, and the course is a science, it's about science. And so it's a really important foundational course in your studies. So fundamentally, a Master of Science degree typically, especially in the field of education, it focuses on the application of scientific principles to, in this case, curriculum and instruction. And that is the science of learning and the science of maximizing the effectiveness of experiences that are designed to help people learn things or instruction. So that's what it means to earn a Master of Science in Curriculum and Instruction. And aren't you glad you know that now? Objective 1.2 asks you to answer the question, what does it mean to think scientifically? And again, another one of these italicized objectives that you're not going to be tested over. But it complements the first objective because an awfully large portion of this class and of your master's program in general is designed to help you learn the skills needed to think more scientifically about being an educator. And what that means essentially is learning the skills needed to take a systematic approach to answering questions and solving problems within your field. And so the systematic approach that is foundational to science is generally regarded as the scientific method. And so that's something that this course is going to focus on as you move forward in the class. And please read through the information about thinking scientifically. Oop, there we go. Because it does have some interesting things to say about bravery and how important it is to think scientifically, especially in today's world. Objective 1.3 asks you to describe science as a way of knowing and then compare or contrast that with other ways of knowing. And I include in the information about different ways of knowing in the course notes references to something that I hope all of you readily understand. And that is, of course, an important scene from probably the most important movie ever made. And if you have never seen Monty Python and the Holy Grail, you should just stop whatever you're doing right now and watch it, because I believe it's on Netflix right now, and it's an important cultural thing, and it's part of my job is to expand your horizons. But this is a very important idea to understand about science, because science is an important way of knowing, and I'm asking you to learn the skills involved in thinking scientifically and in knowing things through science versus other ways. That doesn't mean the other ways are all bad or less than ways of knowing. Oop, there it goes again. Just to wrap up, you're probably sitting in a structure right now, a house where you trust the experts who put it together that it's not going to fall down on top of your head. And so that's it's important to trust the experts. The experts, yes, but we certainly see an awful lot in our world where people are trying to get us to believe that they know something, and they are neither scientific about it nor an expert. So this is an important skill. Objective 4 asks you to differentiate between social science and the natural sciences. And again, this is an italicized skill, so you don't actually have to do this on any of the exams. But I put this in there because I reference social science a lot in the class. And what's really important is, as you learn about scientific methodologies, there are some methodologies that are part of social sciences that are not part of what are called the natural sciences. And so it's important to understand that, and it doesn't make it any less scientific that there are methods that we use to study humans and human behavior, we use methods that are at times different and maybe even at odds with the way that you might study things in a test tube. So that's a very important, there's very important information about that. So objective 1.5 asks you to identify and explain or describes the common steps in the scientific method. And so I include a very detailed diagram of that in the course notes, and then I go through and describe what happens in each of those boxes. So pay careful attention to that. That doesn't mean that's the exact order that everything always goes in when we're using scientific methodologies to help us know things, but it is a very, very common model. Objective 1.6 asks you to define a theory and differentiate a theory from a model. And I put those two concepts together because they are related, and because they oftentimes can be sort of misunderstood, because one models are often thought of or believed to be theoretical or theories, and the word theory gets thrown around a lot when usually the people who use it mean hypothesis. And so there's some really important information in the course notes about the difference between those two, and then a representation of a common model or models in education. So take a look at those. So objective 1.7 asks you to identify the attributes of a good theory. And so they're all listed there, and I want to draw your attention just to the one that is likely the most important and oftentimes understood by a lot of people, and that is that all theories have to be falsifiable. That is, you have to be able to do something to identify if and when the theory could be wrong. That might sound a little bit confusing, but I use a common example in some of the information in the introduction to the course about religion, about religious beliefs, or I should say sort of spiritual beliefs in general. Spiritual beliefs can be very true to a lot of people, but the one thing that makes them not theoretical or not scientific is the fact that you can't falsify someone's spiritual claim. And that may sound a little bit complex, because you could say, well, I can prove that this God exists or that God doesn't exist. But that's not really true if you're having a conversation with somebody about their belief system, and it's not grounded in observations, but something like faith, for example. There can always be a reasonable explanation to an observation that doesn't fit the mold of the faith. And that doesn't mean the faith thing is necessarily wrong. It means it's not scientific. There are theories that are grounded in a belief that can't be falsified aren't good theories. Objective 1.8 asks you to distinguish between definitions and examples of basic and applied research, and that's important in this class, because you're going to be reading a lot about research studies that are examples of applied research, and you're going to be doing planning a project that is fundamentally an applied research project. And so I provide some information and examples in the course notes about the difference between those two. It'll help frame your thinking and how you move forward with the course project, being able to do that objective. 1.9 asks you to differentiate between the purpose and methods of research versus evaluation. And I only have a little bit of information in the course notes about that, but believe me, I could talk for weeks about this particular objective. But fundamentally and methodologically, there isn't a difference between research and evaluation. The whole difference is the purpose. And in research, your purpose is to investigate, is to generate new knowledge by investigating problems and by making hypotheses, or at least identifying hypotheses and pursuing experiences that can support those hypotheses or not. Evaluation is you are simply using the same scientific methodologies, but your purpose is just to prove the effects or the effectiveness of a particular intervention that is just related to your own practice, to what you might be doing at the school or the district level. So that is the fundamental difference. When you do an evaluation experience or exercise, you're solving your own personal problem, and you're not adding to the body of knowledge that supports some fundamental theories in your particular field. Again, basic information included in the course notes. So objective 1.10 asks you to identify the characteristics of a good research problem. And then if I give you a pair of related problems, you should be able to tell me which is a better research problem. And this is very important because, again, you're going to be asked to identify a research problem in the course project. And so there are some better problems than others, and I provide some really fundamental information about that in the course notes. Objective 1.11 asks you to differentiate between definitions and examples of inductive versus deductive research. And so I include in the course notes a really fundamental diagram or picture that kind of illustrates the difference, and pay attention to the way the arrows are moving on inside that diagram. So I like to think of a difference is that in the deductive approach, I am fascinated by the life of Albert Einstein and by all of the things that he was able to think about it in a very theoretical way. And here's somebody who came up with these theories based on kind of mathematical thinking and extrapolations, and then those theories were then communicated, and people then did things to try and test whether or not the hypotheses about problems associated with that theory might be true. And I always find that fascinating. Inductive approach is more common in general, particularly in social sciences, where you start with making lots of observations, and then you recognize patterns from those observations, and then you hypothesize about why those patterns exist, and then begin. Once you do enough investigations, they begin to form theories. So that's a very different approach than sitting, working at the post office and just imagining based on what you understand about math, what something cosmological could be a foundational truth, and then go from there. So that diagram is very helpful, I think. Objective 1.12 asks you to identify definitions and examples of exploratory, descriptive, and explanatory research. And those three different types of research are provided just because they help explain a little bit about why research is conducted, and then you're going to be asked to identify the type of research that your proposed project is going to address. And given the nature of what I'm going to ask you to do in the project, it will likely be descriptive or explanatory. But this objective is about you better understanding the nature of research in general. So for objective 1.13, you need to define the term variable and then distinguish between the different types of variables, dependent, independent, and moderator variables. And this is a really important objective because those terms, those concepts or constructs, they're used just throughout the entire class. And so the information that I provide about the different types are included here, and then you're going to apply this information to one of the later objectives in part 1. Objective 1.14 asks you to define operational definition and then give some examples of operational definitions for various variables or concepts. or constructs. And operational definitions, that is such an important thing. When I was a science teacher, I used to have my students think about variables during investigations and think about, well, how are you going to know when that variable changes, or how do you know when you have that thing in the first place? And so, and I provide some information about that in the course notes. A really good example in education is if you want something that you do for learners to improve their level of satisfaction, for example, about what they're learning about. Well, what does that mean? What does satisfaction mean? How do you know you have a level of satisfaction in somebody, particularly a level of satisfaction about something like something you want them to learn? So the only way scientifically you could investigate is to operationally define satisfaction. And it could be defined by how somebody responds to a statement about satisfaction, or it could be how often you observe students doing things that would reflect a high level of satisfaction. So again, I have some notes about some good examples in the course notes about that. Objective 1.15 asks you to differentiate between propositions and hypotheses. And I will say this, that the term proposition and the term construct are kind of synonymous in this case. And this is an important outcome for you to be able to do, because fundamentally, I want you to really truly understand what a hypothesis is and how to recognize one. And you're going to have to write some hypotheses in your research proposal. And so it's possible the information and examples that I provide in the course notes would help you better understand things that were presented earlier in the course notes, because you'll notice I've already used the construct hypothesis many times earlier in the notes. So anyway, read through the information and examples in the notes, and then possibly go back and reevaluate some of the objectives, like the steps in the scientific method and that sort of thing, once you feel comfortable with what that phrase really means. So objective 1.16 asks you to identify the dependent, independent, and moderator variables that are referenced in hypotheses. And I provide a lot of examples for this in the course notes. But earlier you were asked to be able to describe what the difference is between those three variable types, and then this one asks you to identify them in a hypothesis. And this is really important because it's going to help you, number one, write good hypotheses, and then two, be able to stay organized as you consider how you're going to design good research or interpret research that somebody else has conducted. And finally, objective 1.17 asks you that, well, if you're given a hypothesis, you should be able to determine some of the most likely extraneous variables or control variables that would need to be controlled in a study designed to collect data that could support or not support the veracity of the hypothesis. Wow, that's a lot. And I turn my timer off on this one because this is the last objective for this set, and I'm going to say a little bit more about this because it also connects to the previous objective. And that is, so extraneous variables are things that might have an impact on the independent variable in a study, but you don't want them to, because that's not the variable that you're studying. Well, I should say they might have an impact on the dependent variable, but you don't want them to, not the independent variable. And so in this course, you're going to be asked to consider a problem associated with artificial intelligence in education. And let's just say, for a real simple example, that you were interested in determining whether or not an AI tutor would help improve the not only the what students learned in a particular subject area of your class, but also how they felt about the learning process, improve their attitudes about learning, improve their attitudes about school, increased levels of confidence. So you're interested in those variables. So in a case like that, if you were going to do a simple study where you took a class and half that class was assigned the AI tutor, the other half weren't, they were randomly assigned. So the AI tutoring would be the independent variable. That's the variable that you're manipulating or controlling. The dependent variable, or variables in this case, might be all of the things that I mentioned, things like achievement and confidence and satisfaction and general attitudes about the class, attitudes about learning. Those could all be dependent variables. They're dependent because you presumably believe that that if they change, because they're variables and they're capable of change, if they change, their change would be dependent on whether or not they had the independent variable or not. And there might be some moderator variables that could have an impact on the level of impact, and that moderator variables could be the age of the students, the gender, their comfort level with technology, that kind of thing. But there are other factors. If you were to do that study and you had these two groups, there are certain things that some of those students that could impact those variables, but you don't want them to. A good example would be, what if all the kids that were picked to have the tutors were kids with really low achievement anyway and bad attitudes about school anyway? And that could easily happen if a teacher, as a researcher, decided that they were just going to put the kids in that group who they thought needed it the most. That's an extraneous variable that would need to be controlled. And the way you control it is really simple, and that is you randomly select kids. But if you had a tiny little class, like let's say you only had 4 kids, then the chance of having kids in one of the group or the other with bad attitudes that are going to be difficult to change, then the way you control for that is you get more students. You don't just use an N of 4. Anyway, so that's the information about 1.17. So you're going to review these, review the notes. There is some practice items associated with those objectives. They're on this page at the bottom. And so once you review your notes and study them, take the practice, respond to the practice items, and then contact me if you have any questions about anything. So happy studying. And again, I think some of the information in the first part of the Willingham book does support some of the fundamental concepts that are part of these notes. So there you go.